I got a two-column proof problem today that we're going to fill out and prove that these two triangles are congruent to each other. But not only are we going to fill out this one, we're also going to give you some tips and tricks because two-column proofs can be a little bit tricky. And I'm going to show you some tips that are going to give you a lot of points on tests and quizzes and also make you successful at filling these things out because they're a little daunting, all right? The first tip is whatever you're given, that's going to fill in however many givens you have for those first few lines. In this case, we have 3 givens. And so I can literally take and copy and paste these in line 1, 2, and 3 here. And the reason is going to be given, all right? Let me do that for us. Okay, you'll notice that I haven't even looked at what the problem is saying, really. I just kind of took those first few things and filled them in. I would encourage you to do the same thing on your homework and tests and quizzes, because if you look at the number of lines that we have 7 and 7, that's 14 lines. We already have 6 of those 14 filled in without even really looking at the problem, all right? So it's going to save you a lot of points on tests when otherwise maybe you don't know what to do. Another freebie that we have is this very last one. We're trying to prove this is going to go on our last statements side, and I'm again just going to copy and paste this over here on line 7. Okay, now that we have that all figured out, now let's see if we can maybe get a few more points by actually seeing what this problem is asking. It says, given that BD is congruent to CA. Well, every time I give you something, you can usually either mark up the picture or it's going to help you out with other lines in the proof. So BD here is this long line. It says that's congruent to CA, which is this other one. So because those are congruent to each other, I'm going to give each of those a tick mark. BD and CA is going to have a tick mark. Remember how we have like side, angle, side, angle, side, angle? That's going to be one of those sides that's going to be congruent, one of those 3 things we need in order to prove our triangle's congruent. All right, the next two are similar to each other, and this symbol means perpendicular. So it says AB is perpendicular to BD. Now, because those are perpendicular, what kind of angle is this? Well, it's a right angle. In fact, that's what we're going to have to say next. So I'm going to mark it up now. And same thing for this one. AC is perpendicular to CD. That's this one. But I have to say that in my proof. So because of these 2 lines, I can say that angle ABD and this other one, angle DCA, I'm going to say are right. Okay, and the reason for that, a lot of times when you have kind of a symbol or a word that maybe you only hear in math class, like bisects, midpoints, perpendicular in this case, it's going to be the definition of that thing that's the reason that that's right, okay, or that is the bisector or whatever you're using. So in this case, I'm going to just say it's the definition of perpendicular. Okay, the definition of perpendicular segments here, okay? That's the reason that those angles are right. Okay, now, not only do I have to say they're right, but I also have to say they're congruent to each other. So kind of a gimme line below this one is I can, again, just kind of copy those 2 down, but instead of just saying and, I'm going to say they're congruent to each other, right? We're trying to prove those 2 triangles are congruent, so these 2 angles have to be congruent since they're both right. All right, so I'm going to say angle ABD, just copying these down, is congruent to angle DCA. And the reason for this, well, these were both right angles, and we actually have something that says that all right angles are congruent to each other. You might have learned that as RACT, the right angle congruence theorem, RACT. So that's what I'm going to abbreviate this as. Hopefully your teacher lets you abbreviate. Maybe let me know down below in the comments if they do or not. I know some teachers are sticklers. I tried to be lenient because I know my kids hated proofs, but anyway, those are right angles, so now those are legit on there. Now, if you remember our 5 different ways that we can prove triangles are congruent, I'm going to do this off to the side here. We have side, angle, side, angle, angle, side, angle, side, angle, side, 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 and then hypotenuse leg. All right, well, let's see what we have. I can eliminate the side, side, side because I have an angle that we already have on there. The others, though, I think I have to keep so far. Even the hypotenuse leg, because this is a right angle. In fact, let's just double check this one. The hypotenuse of this right triangle is this bottom segment, and the hypotenuse of this one is that bottom segment. Hey, I think we're onto something because the hypotenuse is shared by both those triangles. If I think it's this triangle here and that triangle there that we're trying to prove are congruent, well, they share this side. So because of that, I'm going to put 2 tick marks, and I'm going to say that AD is congruent to AD for my last line. All right, AD is congruent to AD. The reason that something is congruent to itself is the reflexive property. All right, reflexive. Okay, then this last one, because we said this was hypotenuse leg, we can cross out the other ones. I'm just going to put HL, as that is one of the 5 reasons that we can prove that these triangles are congruent. If you found this proof helpful, or if you need help with other proofs proving that 2 triangles are the same, you might want to watch this video, as it's another 2-column proof.